Okay, so this is going to be a breakdown of a piece of malware called Godfather. It's on Android. So let me show the file structure. So here's the original APK. This one right here, C2B, CC. This is, I've unzipped it. Here's the original zip. Here's the unzipped APK. And then I unzipped that APK to get all of these over here on the right. This is the unzipped APK. Now within the APK, this is the JADX right here, this one, for decompiling this APK. Now this piece of malware is packed, so this is like the first part of the payload. Not too interesting. The only thing it really does is prompt you to install the second part of the payload. And the second part of the payload is right here in the assets directory. Now here's the second part, the malicious payload. Here's the JADX. This is what you see back here. This is the JADX. I've decompiled it. Here's a little a little free script to bypass the root, because there's a root and emulator detection, and that's what this does. Or I think it's just emulator. I should rename that. Let's see. Emulator detect bypass. I'll show this real quick. It's nothing too fancy. Where is... Yeah, you see here, it's just this is the package name. This is awful looking. That's the class, the launch activity. Getting the function call. It's called recalling for the method that does the emulator check. Gets the original value, logs it out, but then I just override it and return false. Now that I think about it, I may have that wrong. Is emulator. Oh no, it'll always return false. Yeah, I want it to return false. Yep. Okay, so this is the launch activity for the second part, the malicious payload. It's quite a bit more complex than, say, Anubis. There's a lot of stages that it goes through. So first, you can see here it gets this country list. These are like the countries, you could say, that are supported, or the languages that are supported for this payload. You can see here, like this string right here. This is another thing it does. All of the strings are they're hidden really well. So you see here, I've renamed the string utils and then decrypt. I go in here. Now the key, the nice thing is that the AES key is hard-coded, so it's easy to pull out. But so yeah, this all gets decrypted, and then this is the plain text right here in the comments. So if you want to look through it, you'll either have to know what the string is, you'll have to look through the comments, or if it's a shorter string, I just rename it. I renamed the string str, like right here, str, please try again. Now this one is actually a string array. This comes back as a string array. You see here, it's typecast to a string array. But it's like this, and that it's delimited by language. So like, please, where did it say? Please try again later. It's actually a giant string, and it's separated by language code. So I just chose English, but it's please try again in all of these languages. But the one you'll see here, like, let's keep going. Here's the on create. Nothing too much going on there. There's a request for permission. Let's go to on resume. All right, there's the emulator check here, which I bypassed with Frida. All right, and then these settings, so even after decrypting all the strings, they're not really all that intuitive. They're kind of, I feel like it's kind of some security by obscurity, like ACCS. I'm not sure what that means. Accounts maybe, or access. I think it might mean access. So, this is just a dialog. It points you, when it launches this activity, it just points you to Google Play Store for a legitimate application. It's like a music, royalty-free music app. Now, I don't know, I don't think there's a connection between that legitimate app and this one. I think they're trying to create a false connection, create the illusion that there's some legitimacy there. Okay, let's go back. So nothing too interesting right there. Min, and then it writes this. This will be relevant later, but this is actually a URL, part of a URL. Okay, then it comes to this try catch right here. It spins up a thread and it tries to make a request to a Telegram channel. This is the URL to the Telegram channel. It's still up. It's just like one user or one member in the channel. But let's look in here real quick. So you can see here, it makes this request, gets your OK HTTP client, makes a request, sets up the header. Then it makes that call, get a response. If it's not successful, throw an exception, else. It gets this, it's looking for this pattern. So it finds it and then writes that, that pattern, getting that from the group. So it looks for that pattern and then writes that group to shared preferences back in that min. And that's where I think this is the next part, or that's where it gets part of the URL for the next part of the attack. So it like gets its instructions from this Telegram channel and then gets to get the URL for the next stage of instructions. Here's a request for notification permissions. Nothing too crazy there. Let's see on, oh yeah, and then if it returns successful, if permissions are granted, it does this, right? Settings to preferences, then request accessibility service. So just like Anubis, this all revolves around accessibility services. One thing that was kind of annoying and tricky that they did, you see here, this is a library from OK HTTP, and they're using right here, this is a constant, which is an empty string, and they're like using that constant as an empty string, and it kind of threw me off because yeah, like I see this constant fragment and code set, and I'm like, what is this? Why does this keep getting set? But it's just using some obscurity to, it's just, all it is an empty string. So I renamed that library, that constant in this library. Okay, then you see here it gets a string array, and it has these NTR, these 3-letter, 4-letter acronyms, 2-letter acronyms, you know, just these two things. These aren't really intuitive, so I don't really know what these are. But you see it gets those, and then what does it do? So makes a string that says false. Okay, it's going to iterate over this whole array, and then gets each element and then writes them to initializes them as false. So these are like settings. I'm not sure what these mean, but there's some kind of settings to determine like the stage of this payload. Now here's the shared preferences I've pulled. Some of these were base 64 encoded, and I've just decoded them. You can see here, like a lot of it's just copy text. Here's where they're getting a list of all the activities installed on the phone with your package manager. But yeah, then there's just like a lot of, you know, like one of those was KY. Some of these might be part of like URLs. they like do like put strings together to make the URL to make it harder to figure out what's going on. So yeah, it writes all those settings, and then more more settings, a whole bunch of settings, writing all these. You see here, like this string, I just wrote string OPC. That's what this string is. Decrypts to string 0. Yeah, a whole bunch of settings being written right here. Okay, then here you see it's going to iterate over like this prokaryote. I didn't rename it, but this prokaryote is the string array split on the colon, right, from this string right here. So it splits on each colon, and that creates an element of the string array. And then you go to where it's used right here, it's going to find the current, so it gets the current language, whatever the locale set on the phone. And then if it doesn't have any of these, it sets it to English. You see right here, EN. So English is the default. But then it's going to look for if it has whatever the current language is, most likely English. And it finds, it searches for the value associated with that language from like right here. So for English, it would be this one. All right, so it's going to do that for a lot of these settings. Here's protect 2020. I think that's Google Play protect string, permission toast, info big. I don't know what all these mean. Oh, gets the right copy for allow, the right toast message, the language specific toast message. Okay, so it does all that, gets a lot of copy. Okay, now it's done. It's done. So that like setting KY is like, I think, have they been set? Okay, so then it shows, let's see, what's this read? If that ACCS, I think it's access, if it contains true, then it shows that that string, where's it at? Again, string again, read from. Okay, what was again? Let's see if it's in here. Here we go. Oh yeah, please try again. So this is the copy from there. So it'll show a toast saying please try again. Then it cuts off the activity. But if it's already been granted, then it's going to start this activity. So that's the request accessibility services activity. Let's step into there. All right, on create gets a handle on the text view. Nothing too crazy there. Sets up your UI elements. Try. Let's see. So let's see. Puts an on-click listener. Okay, so this is like for IDs with like settings from like the system, I think. Settings. Okay, here's two strings. Let's keep going. Intent. Okay, this is Samsung accessibility. Samsung. So this is like handling Samsung phones. Resolve activity. So it's checking to see if there's an activity that can handle this intent. So this is like a check for Samsung. And if there is, or no, if there is not, if it's equal to null. So if this is not a Samsung phone, then it's going to go into the regular accessibility services. So Samsung has their own version of accessibility services. Set some flag. Okay, so it's got the intent built and pointing to the right package. Let's see, get some args. Args is what? Package name and class name. Yeah. So this is the string package name, and then this is the class name. Yeah. So that's the package name. What does it do with these R? So it gets like, it puts that into this bundle, puts an extra. So it does it as a bundle and an extra. Interesting. Puts that in there, sets up the intent. Then it checks for is in keyguard restricted mode or string or screen locked. So this is the negation of that. So is not in keyguard restricted mode and not screen locked. So if that's true, it requests the accessibility service, starts that intent, shows a toast. That toast, let's see, what was the toast message? Oh, here we go. Please grant accessibility permissions to run. So let's go back. So it's prompting you to, as it's requesting the accessibility service, it's prompting you with the toast to allow it. So, and then let's see, there's also a check second time around. So if this is checking if an activity is running or a service in this case. If it's not running, then it's going to start a foreground service. Try to start a foreground service with that malicious service. That's the name I gave it. So let's step into the malicious service. Let's see what's going on here. Okay, on start command right here. Get a handle on the settings. Set up an intent pointing to the Android settings. Get system service. Okay, so it's making a notification in the foreground. So it'll remain persistent. Okay, and then interesting thing right here, if the service is ever destroyed, it sends this broadcast. It sends a broadcast with kill and then this package name. Let's go into this. Oh, yeah, that's an Android one. But we'll check out, actually let's do it right now. Let's check out that receiver. It sends a broadcast. Where's that receiver? Start foreground receiver. So that will start up the malicious service right back up again. So that's all that does. If it's destroyed, it tries to start it right back up. And then it calls these two, I have not named these. So fashion following, what does this do? Scheduled executor. Okay, it gets a new, so yeah, it runs this on a scheduled. So it looks like every 60 seconds, it's going to run this. It's going to run this code. So what's in here? String OPC, another 3-letter acronym. I don't know what it is. Runs this function. What is this? So checks to see if AC, I think that's access. If access is true, it calls that Telegram channel again. And remember, when calling that Telegram channel, it writes all the settings from what it gets back on that Telegram channel. It'll write that. No, malicious service. Okay, then see, same thing. Check if okay. So is in keyguard restricted input mode. If it's not in that mode and it's not screen locked, it makes this flag. It's either a 1 or a 0, and then it tries this. What is this? So this looks like some strings, and then that puts that in this hash map. So it's going to get these settings. What is this second one? Tag. What is TG and tag? Let's see if those are in here. Okay, so it's this, and then what's TG? I don't know. Oh, no, that's just the key for the, I see. That's not in the shared preferences. This is just getting that string right here. This is reading it from shared preferences. Okay, so put that all in there. And you see here's the key, the hash map with the key and value. CY locale, model, SMM. And then you can see right here, it makes this request, but look at it. It calls this function reads from shared preferences. So it reads the value from min and then decrypts that. So let's do that. Oh, actually, I'll do that later. But yeah, it reads the value from min, decrypts it, and then appends it to this z.php. And that gives you the URL. Actually, let me see if I can hunt that. We'll try to hunt that down. I think I mistakenly base64 decoded it, but it looks like I now see it should be decrypted. So it's double encrypted. Okay. But yeah, that'll give you the URL that it's talking to. Where did I leave off at? Right here. Okay. Then it calls this function, makes another request, same thing here. Calls all this. This gives you have to decrypt it with this function. Decrypt one, where'd it go? This function. Here's the decrypt, another decrypt function. What is it? Gets blowfish, and then cipher instance, decrypts it, but then it passes it here, decrypts it, gets the IV, yeah, so hard-coded IV. Interesting, okay. Okay, then let's see, checks if pro check is okay, and if it is, start handler to check safety verification. So this is a really interesting thing. It's using, you see here, like this starts it, this is a handler, and then going to here. It uses like Google Play's safety nets. You see, this is, this safety net is from Google. So it's using Google's like safety, anti-malware services, anti-malicious behavior services to protect itself. Kind of interesting. Where was it? Malicious service. Yeah, so checks that. Okay, if it's successful. So what this stops you from doing is if you were to take this, reverse engineer it, and then modify the Smalley code, compile it, sign it, zip align it, and install it, this would fail. This would tell the Google would protect them, would not allow it to, or like basically they would know that you've modified this app. Their malware. Okay, a couple handles. Let's see, verify app settings, activity. Yeah, so then it takes you there to the verify app settings from Google. Let's keep going. Let's look at some more ones. They ignore, this is all like, there's a lot of work going on in the background, and eventually I'll show it. It connects to a socket where it's always relaying your, well, I'll get to it later, but basically there's a check to make sure battery optimizations is turned off, because the battery optimizations will start to turn off services and kill activities if you're running low on battery. And this this is disabling that, or not allowing it to the system to shut it off or kill its services. Show this app detail setting, so you can just contains. So if this contains S shutdown, so this is kind of like there's like kill switches in here. If it contains SMSG, shut the service down. Else open. So I don't know what SMSG is. I'm not sure. But then there's also a device check, and this is important for like system alerts. It checks if you're on Huawei, Pixel, LG, CPH is Cloud Phone. That is Xiaomi. I can't remember what OPPO is, but it does a check to see what kind of phone you have, because that will kind of determine the UI and layout for like your system settings or where things are positioned on your screen. And that becomes really relevant for the accessibility service. You see here, like there's all these OPI, I don't know what that is. Dialogue intent, what is that? My web view, it starts a web view. Not sure. All pin, where is this called? Okay, yeah, so I don't know. This looks kind of malicious though. Something with your pin and then starting an activity with that. What happens when we step into that my web view activity if we pass in that extra all pin and 1500? Another interesting thing here, Rabota, that's Russian for job. Like I'm thinking in the context of computer science, like you're running a job, or an Android, like a scheduled job with Work Manager. So it loads this URL. You can see here it's all piecemealed together. The URL. Does it ever fire off the extras it passes to here? I don't see it. Let's see. Oh, get intent. Yeah, there you go. Okay. String and ID. So it does get those extras and it passes them. Does it use them anywhere? Okay, it just checks to make sure they're not null. Oh, it uses them right here. Okay. All right, interesting. Let's close some of these. Let's see. It does a check to see and writes them to the shared preferences. What is this alt? Let's look up alt. Let's see if I have it here. Oh, here we go, alt. So yeah, it writes the packages of all of the apps I have on my phone, and from there they can discern, if there's a banking app or an authenticator app or maybe an app that could detect that there's malware on their phone, they can behave accordingly. Show malicious notification, nothing too interesting there. Okay, then it just repeats this job to this task, timer task, to show a notification. What is it? Stop accessibility service if condition. So there's a condition to stop the accessibility service too. Let's see where this is called. Right here. Tries to stop it. What's in this? Okay, so yeah, it'll get a command back from, what is this? Make request. So if it gets a command back, it will stop the accessibility service. Let's look at, was it here? Socket? No, not this one. Request accessibility service. Let's go to the top. Yeah, so this is the really interesting one. This is where all the magic's happening. Checking if is activity running. So you pass it a certain class name or a class, and it checks to see if it's running. Foreground service. So if malicious, okay, that restarts it. Okay, that's to request it. Here's the actual accessibility service. Let's go to the top. This is where all the magic's happening right here. So let's see. Create, gets a window manager, write some things, update some settings on the shared preferences, SY2, checks to see if it's Samsung. Okay, then on accessibility events. So this is like accessibility event is like something showed up on the screen, like your UI changed, anything on the window. And let's see, so let's see where something interesting. More with the settings. If contains, what is contains? Oh, so if that SMSG contains open. So I think that might be like a flag letting them know like, hey, accessibility services has been granted. SMS granted, maybe. Like maybe that's what they're really attacking is SMS. They want to read messages for like OTP codes or something. And then here you go, I equals, so looking for version, build version 27, different one, 28, and 29. You see here, these are different, yeah, so it's like looking for all of these. Yeah, it looks for what, ID left button, ID button 1 negative, and then you see button 2. So these are like the different IDs, different versions of Android give this same button. Else, what is this? If settings, click KK. I don't know what that means, some kind of setting. So it could be ID 5555 or button 2 for Android 29. And then you see here, button 2, else button 2. And then if something comes back, so if it's not null, meaning there's other UI elements within that tree, that UI tree, it's going to perform an action. Action 16 is click. So it's going to automatically click that button for you, which you may or may not want to do. And then see, click KK, OK. What is this? Right to shared preferences. Oh, I got this wrong. Oh, let me do that. Okay. Yeah, rights to shared preferences. Okay, so then it does a device type check, and then the string. Okay, so if it SMSG does not contain open, else. So it's updating this R9 string. Okay, then it tries to do this. It's doing the version check to do the appropriate behavior. Button ID 1 or button 1 ID. So there's a specific button from the Android settings that it wants to get a handle on. Checks to see if it exists. That's what this, if the size is less than or equal to 0. So that would be if there's nothing there. Else there is something there. Okay, gesture swipe down and right. So it performs this gesture. 16, I think I said it was okay. Okay, so no, that's swipe down and right. Let me put that here. So it performs that gesture. Puts the number 33 right there. I don't know. So let's see. Let's see. R9 was a string, and now it's an integer. Maybe it auto boxes it to a string. I'm not sure. This also had a problem decompiling it, so maybe this might not be perfect. You see, if it's tiramisu 33. Okay, it performs, let's see, what does it do? It says SMSG true, and then perform global action. That's clicking the back button for 1. 2 is the home button. Else if it's 29. So it looks like it's trying to back out of a screen. And then what is this? 29, SMSG true. Else if 28, same thing. SMSG true, back button, home button. Does it on a handler though, or all these are? This one, okay, does these two on a handler, this one not on a handler. So it does it on the, that's weird. I wonder why it does that. Okay, so I don't know why it does it for those. For some reason, 28 and 29 does it on the background thread. For this one, it does not. It does it on the main thread. Okay, then else, what is this? Checked on 27. Background thread again, same thing. SMS set it to true. Click the back button, click the home button. Oh, so it does it on the background thread and the main thread. Okay, weird. This might just be bad coding. That's what I would probably guess. Is FSS false? Another setting, checking there. It checks to see if it's equal to 5, which is Xiaomi. Or Xiaomi, I don't know how to say it. So if it's false, what does it do? Checks another setting. Writes it, changes that setting, and then start ignoring battery optimizations. What does this do? Okay, so this is gets the main intent, sets the class to okay, whatever the package. So that's what it's going to set it to, package. What is that setting? So yeah, this is the, it's going to say this package. So it's going to try to, it looks like it's going to try to run this APK. Let me update that. Oh, what was the other one? Packages. TP. Let's look that up. Okay, so this is like the specific class it wants to run or step into. The botanics. Oh, it sets a flag and then says drop OK, and it starts that activity. Okay. What was the botanics? Is this the botanics? Let's search for botanics. It's gonna be in a comment. No, you know what? It might either. I think it might be in the first part of the payload. That's why it's getting the. Yeah, I think that makes more sense. It's on the old payload. Where's it at? Does it say? Oh yeah, okay. So on this package, yeah, this is from the first part of the payload. This is from this one. Can I open this up? Oh no, I didn't want to do that. Anyways, I remember this is from the first payload. Where's it at? It's from this one, the initial payload. We're looking at this one right now. We're looking at this one. So that's where that's from. Okay, it puts something in the extras, drop OK, and then fires that off. Okay, writes some settings. Does a check for if it's not Xiaomi or not cloud phone. Okay, and then it writes screen width and height to shared preferences. All right, so what's next? I want to get to where, let's just skip. These are all settings and stuff. This, yeah, so here, let's see, what is it? Okay, so this is looking for This is a regex, and it's finding is password node. So it's looking for pin entry. It's traversing your UI for pin entry, password entry, fixed pin entry. So anywhere you're entering a pin, so it's searching for that. And then let's see some other ones. A lot of math for the screen. Okay, here's where it makes a request. That's to the URL. What is this? This is for 5, some setting. Okay, I'm not gonna go in there yet. So check to see if it's a password node. I want to see the one where there's where it gets a socket. Let's see. Okay, here we go. So when this is called, let's see where this is called. A couple places. Right here, pass it 0. Right here, passes it 0 again. So this checks if A contains 0. It's going to say cancel this. But if it doesn't contain 0, it's going to run all this. And what this does is it traverses the nodes in the get inactive window. So whatever's in get inactive window, and then it sends that back. It traverses your UI. You see get bounds in screen node info. So you pass it that node info, and it's going to traverse over your screen, and then it's going to put the details on into this data structure, this JSON object, and then turns it into bytes, or no, it turns it into a string, and then sends data through the WebSocket, but it's going to iterate over this. So it traverses the whole thing and just keeps calling this, sends the data through a WebSocket. So that's kind of interesting. It latches on a socket to send all this, whatever is on your screen, they're always going to know what's on your screen based off what's being passed around. And you see here, this is the WebSocket from this screen. I was not able to rename this. I don't really know a good name for this, but yeah, you see here, start, more settings, WBS. Yeah, there's a lot of code that couldn't be decompiled or had errors doing it. And there's also a measurement of how long things are going on for, the duration, more settings. But yeah, this is pretty interesting. It's once that socket's connected, it's always traversing your the UI and sending whatever. So every time you move around, navigate through your phone, it's going to always be sending what are the UI elements on your screen. I think I want to show one last thing. Let's see. Actually, no, I'll just keep it there. But yeah, pretty interesting piece of malware, far more sophisticated than Anubis, I think, and a lot trickier to decompile and deobfuscate. But yeah, you see that if it's with that function right there, right here, you see call that Latin. Where's this called? Okay, so yeah, these are two commands from Where is it getting this from? Okay, so it gets that that network request body. Um, does it say the URL? Was I able to get that? Add header. Okay, so it's all this URL. Oh, there it is. URL. So whatever URL right here. Once it does that, where'd that go? There's a certain one. It gets a certain node in that response and writes it here to determine whether or not to start that. Where was it? It was this one. This is where it will start the WebSocket and listen. Right here. So depending on whatever these values are that come from the network request, it will run this. Okay, yeah, so first it'll close it if it's open, and then it's going to call this, and then A will not contain that, and it'll run this and send that back to the C2 server. So pretty interesting piece of malware. Hope you enjoyed this. This is going to be on my GitHub, all of this code, so you can see use all the work I've done to deobfuscate, add to it however you'd like. And then also I'll put a link to this right here. This is a simple app I made to help decrypt decrypt all of their those strings. So you can see here stringutils.decrypt. That's going to match. That's going to match what I've put, or it's going to match the code in the JDEX project. And then there's this one. Where is it? Mass decryptor. This is for just copying and pasting chunks of code, and then just searching through it. Searching through it to basically just just searches through it and finds the text that's encrypted. It gets that string. It searches for the apostrophes, and so if you want to bulk decrypt this, instead of copying and pasting each one, you can just copy and paste chunks of code and let it run. But yeah, these will be in my GitHub. Thanks for watching. All right, so I wanted to give a demo of this Godfather malware. And so here we go. Here's the malicious APK. This is the first part. I'm going to install it. Get this out of the way. All right, so I've installed it. It's this music ein Dyer. I click that. I don't know what this is saying. It's not translating correctly. I don't know what language that is. Okay, I click OK. Now it's asking to install an unknown app. The unknown app is the second part of the payload. I click allow, go back, click OK. Some other weird language. I hit Euclid, which I think is okay. Do I want to install this? Install. All right, now it's installed the malicious payload. You can see here it's giving you instructions, and it's going to keep hitting that notification. But it gives you instructions on how to grant it accessibility services. All right, so hit OK. Please grant. All right, let's do that. Let's give it a shortcut. Allow that. Got it. Grant it there. And you see a pop-up right there. So it just showed up and it hit OK because you've granted accessibility services. Now I think this is just some misdirection. Trying to create a connection to a legitimate app. I don't know if this is legit, but I assume it is. It's still in the Play Store. All right, so I also want to show one more thing, the URL. So let's get a ADB shell into this emulator. Let's get root. Okay, then I want a CD into the shared preferences. Okay, so it's this one, ophthalmologic salicylize. All right, com.opthol. Okay, go in there, go into the shared preferences. All right, there's the app.xml, so I'm going to cat that out. Okay, so right here you can see this is that min, so it's reading. I got to see what's the setting for min. That's the first part of the URL. Okay, so where's min? Right there. So I'm going to copy this, and I want to decrypt it, because you can see here. All right, so that's the value in shared preferences. Let me see, go back to the code. All right, so I read that from shared preferences, and I got to decrypt it. So where's this decrypt function? Do I have this? Have I done this decrypt one? Let me see. Do I have network utils? Do I have decrypt? All right, you know what? This is what I'm going to do. I'm going to put this, because it's a decrypt one calls decrypt 2, so I need both of these functions in here. Copy these over, paste them over. Hopefully it gets it right. Okay, this is calling the decrypt from string utils, and it turns into string blowfish. I could just, I'll just keep it like that. Same thing here. All right. What's this? Decrypt. And is this from string utils as well as decrypt? Yeah, string utils, decrypt. Oops. Go back. Okay. So I need to call this decrypt 1. Go into my main activity. What was that in? Network utils decrypt 1. Oh, that's not it. I got to get the value from min. Where was it? Where was min? Right there. I got to decrypt this. Now let's run it. Let's see what happens. What doesn't it like? Oh, it doesn't like this. So that's just an empty string. All right, let's try it again. Doesn't like something else. Oh, same thing here. What the hell is that? All right. So let's see. Let's see what the logcat says. Okay, here we go. Bavosa.icu. I'm not going to click that. What's that website? Virus total, that's one. Let's see. Let's copy that over. Oh, it's been flagged by Kaspersky. Okay. I don't know what .icu. What is ICU country domain? Oh wait, I forgot. I forgot to add. Let's see. Go back to the code. It would actually be. Where is it? this one. So it would add Z and PHP, right? After it gets decrypted, it appends z.php. Yeah, so there we go. That's what the actual domain would be. So let's see if there's any more. I can't remember if I did other ones. Here's another one. Network utils. So what's in this? Min. Okay, so it would be min. I get that URL from min, whatever it was. What was it? Bavosa.icu slash, and then it would add this rx slash f.php f equals, what would it add? F equals whatever this string is. Oh, the ID. Okay. I don't feel like going through all that, but I got one of them, and virus total says it's malicious. So yeah, I will I will add all this to my GitHub, and you can have fun with it.